A conditional statement is made up of two parts. The first part is an hypothesis, and the second part is a conclusion. The hypothesis is the part of the sentence that we're going to assume is true, and we're going to conclude our conclusion. In our first example, if a car starts, then the battery is charged. This first part of our statement is the hypothesis. The second part is our conclusion. So if we look at this statement, if a car starts, we're going to assume the car starts, then the battery is charged. Well, that statement is true. The hypothesis is the car starts. We're going to assume that the car does start, so our hypothesis is true, and then we're going to conclude the battery is charged. If our hypothesis is not true, like we have a car that doesn't start, we can't make any conclusions. But if we do have a car that starts, we can conclude the battery is charged. The converse of this statement is when we flip around the conclusion and the hypothesis. So I'm going to rewrite this statement as its converse. If the battery is charged, then the car starts. So I'm going to assume that the battery is charged and conclude that the car starts. Is this converse true or false? Well, can we have a car with a charged battery that doesn't start? The answer is, yeah, I can have a car that doesn't start that has a charged battery. So is this converse true or false? Well, this converse has to be false. And if it's false, we have to come up with a counterexample. A counterexample is one example that makes the hypothesis true, but the conclusion false. So if I think of an example where I can have a car that doesn't start and has a charged battery, I've come up with a counterexample. Well, if I have a car that has no gas in it, it's not going to start. So my counterexample is going to be a car with no gas. But I have to make sure that my hypothesis is also true. So a car with no gas and a charged battery. So this counterexample makes my hypothesis true and my conclusion false. If I look at postulate number 5, postulate number 5 is a if-then statement. If there exists 2 points, my hypothesis, if I have 2 points, then there is one line through them. If I have 2 points, there's only one line that connects those 2 points. That statement makes up postulate 5. The hypothesis is there are 2 distinct points. Distinct just means different. If I just have 2 points right on top of each other, they're not distinct. So I need a point here and a point here. So if I have 2 points, I can conclude there is one line through them. The converse of that statement if I flip around my conclusion and my hypothesis, if there is a line, then there are two distinct points on it. In the converse, I'm going to first start with my line. And then I'm going to conclude that there are two distinct points on it. Well, a line is really a collection of points. So are there two points on the line? Well, yeah, here's a point and here's a point. In fact, there's an infinite number of points on this line. So there are two. In math, when we say there are two, we mean two or more. The converse of this statement is also true. In fact, the converse makes up postulate 6. If we look at postulate 5 and its converse, postulate 6, they're both true. Different than our first example, where our original was true and our converse was false, we can rewrite two statements if both the original and its converse are true. And we can rewrite that as an if and only if statement. So here's how I'm going to do that. I'm going to say this: a line is formed if and only if there are two distinct points. What this allows me to do, if and only if, I can start here with my hypothesis and conclude that there are two distinct points. If I have a line, then there are at least two distinct points on it. Or I could go the other way because of this if and only if part. If I have two distinct points, then a line is formed. So in order to form a line, I need 2 points, at least 2 points. And if I have 2 points, I form a line.